In this video, we will look into 1.2.3 types of functions. We will go over definitions such as domain, range, codomain, surjective, injective, and bijective. Some of the background information that you already have is that you know what the definition of a function is and how to find one. So let's begin with the definition. If we have a function and it is viewed as a subset of the Cartesian cross product A cross B, then the set of all elements of A that appear will be called the domain of a function. The set of all elements of B that appear will be called the range of a function. Notice how the range is only the elements in set B that are appearing, i.e. that are being used by the pieces of A. Next definition is that if we have a function and it is viewed as a subset of the Cartesian cross product A cross B, then the set B is called the codomain of the function. So B, when it has all elements in B are used, it is known as the codomain of the function. Next definition is if a function f from A to B is called surjective or is said to map A onto B if the B equals the range of f. So let's look at an example. We have two sets, A and B, and if the function maps the elements of A onto every element in B, which means that the entire codomain is used as the range, then this function is called surjective. The next definition is if a function f from A to B is called injective or one-to-one, if for all A and A prime in A, f of A equals f of A prime implies that A is equal to A prime. So let's look at an example of this one. We have a set A and a set B. And if we map A onto B, or A to B, each element in B is only used once. And it's okay in injective if the codomain is not equal to the range because it is just injective, but each element in B needs to be only used once. And that is an injective function. Lastly, we have a function f from A to B is called bijective if it is both surjective and injective. So again, let's look at an example. We have a set A and a set B, and we see that we can map A onto B with each element in B being used, making it surjective, and each element in B is only being used once. It's only being mapped to once. So this is called bijective because it meets both surjective and injective.